Good morning to all of you. Good morning to all of you.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Good morning to all of you. Let's start today's topic. In the previous class, we learned about what is energy and what are the types of energy and why the electrical energy is more convenient energy. That's all. Then we move ahead and learn about the load factor or load diversity. Not load factor, we learn about load diversity. What is load diversity? In the previous class, I just tell that throughout the day, the load demand is not constant. In the night, the demand is less, and the demand is rise with time, and it will increase. And in the evening, the maximum demand is required, and the load demand is varying throughout the day as well as season also. In our country, in the summer, the power requirement or load requirement is more, and in winter season, we are produce or our requirement of power is less. But in cold countries, the power requirement is just reverse. In the winter, they need more power, and in summer season, they require less power. Can you tell me why they have more power used in winter and less power
Yes, sir.
consumed in summer? Can you tell
Yes,
me?
uh, we use like refrigerator, AC, fan,
Yes. We use
which
more.
comes under the
We use more power in summer because we have to uh, use the AC or air cooler to make a comfortable temperature for us. But in case of winter or cold countries, they will need more power in winter, but they consume less power in summer. Why? We are consuming more power in summer, but they are consuming more power in winter. Why? Suppose in USA, England, they are more consuming power in winter. Why?
as the temperature in the winters go around 0 degree in most of the localities of that area. So they
Okay,
are using heaters in
good,
a huge quantity
good,
as
good,
compared to India.
good, good. That's all. That means they are using room heater or something like that, so that they can make a comfortable temperature in winter season. But in summer, they have temperature rise and they feel comfortable on that summer more. Though the temperature decreases in winter, say they are using room heater, so they consume more power in winter. But suppose in our campus area, in which season we use more power and in which season we uh, consume less power in our campus.
So during the summers, we consume more power as we are on Tropic of Cancer, and the direct sunlight falls on most of the localities of Jharkhand as well as India. So
Okay,
the temperature rises higher in our area in summer. So we are using uh, air conditioners to minimize the temperature.
okay. And in our campus, when we use more power and when we use less power,
So during summers, we use more power in our campus.
and during summer, and in case of summer vacation, when the summer vacation are coming, then we use more power or less power.
Less power.
Less power. That means when the uh, vacation are coming, then we consume less power, and when our classes is going on, and then we consume more power. So so the normal graph of power with time is like that. Our power demand, the curve is like that with respect to time. But the power provider, that means the power generating station, what they want, they want supplying varying power or fixed power. What they want?
Fixed power.
Fixed
Fixed.
power. Good. Suppose this is their power supplier are trying to supply this power. With respect to generation, we are saying that at night we are consuming less power, and in evening we are consuming more power. This is power. This is time. Now, how to solve this problem, or how to minimize these differences? The power supplier want that they that they want that they supply the fixed power, but our demand is varying. How to minimize this diversity? Can anyone tell me how to minimize this diversity? We can easily see that the demand of electricity is varying from day to day or in season also, but the supply want to provide fixed power. But how to solve these differences? Can anyone tell me? If in all area the power consumption or peak power consumption is at same time, am I audible?
Yes, sir.
Yes, sir. In all the region the power peak power consumption at same time, yes or no?
No, sir.
No.
No,
That
sir.
means
No, sir.
if the power peak are not same at the same time, so we can make a interconnected between this area where the peak demand is not necessary, then we can supply that power to the peak demand area. Suppose a area have peak demand and another have not peak demand, then we can make an interchange or interconnected grid by which we can provide power in peak region from less peak region. This is a method by which we can minimize the diversity between the load demand and the power generation. Can I do that? Have you understand that?
Yes, sir.
Suppose there is two area. One area have peak demand and another is 75% of peak demand. Then we make a interconnected grid between them, and from the less power demand area we are supplying in peak demand area. So we make A power the we make a equalization between the power consumption, so we make a stable power system. The next, what can I do? Suppose in the peak demand, we use such power generating system that is less cost effective, but surely we get some power from that, like oil or diesel generating station. We can run that time when the peak demand is required, by which we also minimize our minimize the difference between the power demand and the power generation. And the next method is our topic, energy storage system. By energy storage system, we what we do, when the less demand is required, we make some storage by which we store the electricity, and when the peak demand is coming, then we supply that energy on that time. Can I do that? Can we do that? Ritesh,
Yes, sir. But how we can store energy?
this is another issue, but what we are doing, when the less demand is required, we store that electric energy, and when the peak demand is coming, we supply that power from the storage. Can we do that?
Yes, sir.
Yes, sir.
Okay. By this means we also stabilize the system. Okay. The next. Now tell me, what is the characteristics of electricity? It is a fixed or varying. When we generate the power and all the power are consumed at the same time.
No, sir.
No, sir.
So what will happen there? We are consuming power and we are generating power, but the generating station are supplying some power, but all the power are not consumed at the same time. That means when the less peak is demand, the demand is less, then we are not consuming all the electricity. But when the peak demand is coming, we consume all the power. The next topic is the electricity and the role of energy storage system. Why we need energy storage system? When the peak demand is coming, then the cost of electric power generation is high or less. When the peak demand is coming, then the cost of generation is high or low. Ritesh, can you tell me?
Yes, sir. High
High. Why?
because demand is more.
Because the demand is more and we are generating from less cost effective generating station. In the previously I draw that when the peak demand is coming and the generating station are provided base suppose base power at fixed power, but when the peak is coming then we use then we use oil generating station or diesel generating station to supply that power. That means the high costing of generation at the peak demand period. Have you understand that? It is
Ye-
Yes, sir.
okay. Then need for continuous and flexible supply. The next point is when in the when we view the end of consumer, what they want,
Continuous power supply.
they want that the continuous power supply. But what about they what they want the about tariff when the power demand is peak time, then the costing of unit is high, but when the less demand or power consumption is less, then the unit cost is less. In the respect to customer, what they want, the price of unit is varying or fixed.
Fixed.
Fixed, but it is not possible because the generation costing of power is varying. The generation cost of power is varying. So with respect to that point, the need for continuous and flexible supply, we make some energy storage system by which we can supply the power when the peak demand is coming or peak requirement is coming, then we supply from the energy storage system, so we can provide the power to the consumer or customer with continuously and flexible and also fixed price. So the next point is long distance between generation and consumption. Where the locality is situated, the power plant are there or the power plant are far away from the consumption area.
Far away from consumption area.
Far away from consumption area. So is there any interruption between is there any interruption of power due to the long distance of generating station and consumption area?
Yes, sir.
Tell me what is that?
First, cost will increase.
Cost will increase. Then
Then more tower, cables, insulators are required.
are required. So the price of the electricity is increasing. I'm saying that is there any interruption between power in power between and the generation station and consumption area due to the long distance?
During rainy season,
During rainy season, the power is mostly interrupt. Why?
due to wind pressure
Due to the wind pressure.
and
That means uh,
lightning, sir.
lightning and some cyclone are also coming. That means due to the natural disaster, the power failure may be occurred.
Yes, sir.
And is there any fault due to the aging effect of transmission line or any substation? Is it possible? Is there any fault due to the aging effect of any equipment of transmission line or substations like that?
Yes, sir. But it's having very long life.
Though it have very long life, but it has also it may be fault. It may be fault. This is called actually there are two types of problem is there. One is natural disaster, another is artificial cause. Due to the power interruption is happened in long distance transmission line. How to minimize this interruption by using ESS or energy storage system? Suppose we have energy storage system in a substation or consumer side. If the power interruption happen, we supply power from the storage system. By this, we can minimize the interruption. Can we do that?
Yes, sir.
Okay. Then the next point is congestion of power grid. Tell me how much current is flowing through a transmission line, in which factor that depend they depend or the current depend the flow actually the rate of flow of current is depend on which factor? There are two end, one is supply end, another is consumer end, and in between there is transmission line. How much power is flowing or current is flowing from supply to consumer end, in which factor they depend? Can you tell me? Can anyone? Deepak, Priti, Rahul, Ritesh, Akshay. How much current or power flowing from supply to consumer end? In which factor they depend? The value of current or power is depend the
Length of transmission line.
load of the transmission line and how much power is consuming. That means in some time the power when the power demand is high, then power flowing through the power grid is high. Am I right? When the power demand is high, then power or current flowing through the transmission line is high. That means overload may be possible or may be happen. Overload may be happen. Suppose in some time when the power demand is more than the supply end, then what will happen? Can anyone tell me? You have studied power system. In consumer end, the load demand is more than the supply system. What will happen? Can anyone tell me?
Guarantee effect.
What? Suppose I have a generating station by which I supplying some power, but the demand is more than the generation. What will happen? Is the voltage and frequency of the supply system is fixed or varying? When the demand is more than the generation or supply station, then what will happen on voltage and frequency? Are the voltages fixed or it will decrease gradually? Tell me. Suppose a alternator is running and the load is more than the supply of alternator. What will happen? Am I audible?
Yes, sir.
Now tell me. You have learned machine 1, machine 2. If the load is increased, then the voltage and frequency of alternator will decrease. And in grid system, there is a unbalanced system occurred, and due to the unbalancing, the power interruption happened. Is it clear what happened when the demand is more than the generating supply? Is it clear to you now? Ritesh?
Yes, sir.
Is it clear to now? What will happen when the demand is more than the generating supply?
Sir, it's only theoretically or any practical thing
No,
means
in
any proof.
practically, in once in India there is mo- the power cut is entire India. Do you have heard that? In India, once the power cut in whole India happen due to the some state taking more power without informing the generating station, because in one gate there are several generating station are connected. When the demand is more, then the voltage and frequency of that gate system is fall. At that time the synchronization is mismatch between alternator and that grid system, so the generating station are not giving the supply to the grid, and the power on that grid are very less, and the total system is collapsed. Okay, the next topic is transmission by cable. Suppose if we are supplying some area, there should be a transmission cable. There should be a transmission cable or not? Suppose I want to giving a supply in area, there should be a transmission line or not? Is there any requirement of transmission line to giving supply? It is.
Yes, sir.
If there is no transmission line, how we provide the electricity?
From solar.
On solar. On solar. Okay, then any other method?
Wind.
No, there is no transmission line. Suppose you have a generating station far away, but there is no transmission line between the consumer end to the generation end. Then how will provide the electricity to the consumers?
Underground cable.
No, there is no cable.
No possible, sir.
Not possible. But by means of energy storage system, we can provide the power to that area. Suppose we have a storage system, we store the power on that, then we uh, transport that power on that area, then we can supply. We transport by vehicles. We transport that power by vehicles. Suppose we charge some batteries, and we transport that batteries on that area, and by that area or by that batteries we supplying the power to the consumer. If there is no cable on that area, is it also possible?
Yes, sir.
The next, okay, emerging needs of energy storage system. The fossil fuel are consuming now, and they have ending more and more day by day. What the fossil fuel situation? They have large quantity or they are just decaying? Deepak,
Yes, sir.
what is the situation of fossil fuel? In thermal power plant, we consume coal, and in diesel engine, we consume diesel. These are the fossil fuel and non-renewable energy. They are decaying rapidly.
Yes, sir.
So we have to use more renewable energy. We have to use more renewable energy. Suppose, uh, what are the renewable energies? The example of renewable energies. Give me some example.
Solar, wind,
Solar, wind,
Hydro, solar, wind.
hydro
geothermal.
is renewable also,
We get very less power in wind or solar.
and it also weather dependent.
Yes, sir.
So where the grid are situated, that means there if there is cable or transmission cable, by we can merge or we can synchronize all the renewable energy on grid, and we can give supply to that area. And where the grid are not present, and where the grid are not present, we can transport the electricity by energy storage system, and we can supply there. And we have to use now smart grid. Can anyone tell me what is smart grid and in which topology the smart grid is working? Avinash, have you heard that smart grid?
No, sir.
And anyone, have you heard that smart grid? Have you heard that? What is, can anyone tell me what is smart grid? Actually, smart grid is such that by which we can flow the power in both directions. The smart grid topology is such that we can flow a power by smart grid in both directions. That means power can flow from supply into a consumer end, and it also reverse. That means power can also flow from consumer end to supply end. Or you can say there is a grid by which we can the consumer taking power and also giving the power. That is smart grid. Suppose we have a solar system, and a grid is by, actually we have supply by grid or wire or transmission line, and we have a separate solar system. When the peak demand of, when we have peak demand, we are giving supply from the grid as well as solar system. But when the peak demand is not occur, that means there is less peak demand or peak or power consumption is less, then we can sell our electricity, which is producing by solar system to the grid. This is basically it is smart grid system. Now our next topic is the roles of electric energy storage technology. The roles of electrical energy storage technologies. The role from the viewpoint of utility. That means when the power peak demand is occurred, the utility say that we are giving a base power and the consumer are shifting their power consumption in less peak demand. The utility are trying that such that the peak demand, when the peak demand is occurred, then the consumer are not consuming more power, and when the less power or peak demand is less, then the consumer should consume more power at that time. But what is the role of viewpoint of consumers? They want that the fixed charge throughout the day or throughout all the time. So they don't want to switch their power consumption from one time to another time. They just want that we have need power so we can consume. The role from the viewpoint of generators of renewable energy. What is that? Suppose we are supplying from the solar system. We are supplying the power from solar system. What will happen? It depends on the season and weather, and the synchronization of that power to the grid is make problem of stability of the grid. So we have to work on that, and we have to use more energy storage technology with respect to stabilize or balancing the power system. That's all for today. Thank you for joining the class. Now you may leave now.